or first part of a series of videos we're going to do on guitar making. Before we start, we're just going to get kind of a basic anatomy of a guitar. We're going to talk about the body, which is all of the box, the sound box of the guitar, several components. The other component is the neck. The body consists of the top, sides, and the bottom, or the back, I call it. The bridge, the saddle, bridge pins, rosette. On the inside of the back, there is bracing. You can see one there. And on the underside of the top, there's bracing also. We'll talk about all of those in other videos, but this is just an overview of the basic structure. We have the frets. On the side of the fretboard, sometimes we have binding. This has a little piece of wood from here to here. Sometimes we make them, sometimes we don't. And then we have the neck, the heel, the neck, the nut, the tuners or machines. Inside of the neck, we have a truss rod. You can't see it here. We'll go through all that. This is the truss rod cover. This part from the nut back is the peg head. And then there is a peg head veneer that goes on top of that. That's the quick anatomy of a guitar. This particular guitar is not my usual. This is made from metasequoia top, liquid ambar sides and back, and a liquid ambar neck with apricot fretboard and apricot peghead veneer. And I believe we have an apricot, it looks like walnut bridge. That is a quick overview of the anatomy. This is a normal 6-string guitar. What we have here is an overview of all of the fixtures that I've made. All these you can buy them at a store, StuMac or one of those. But when I decided to make guitars several years ago, I wanted to make everything that I could. The only thing I don't make are the tuners. Right there they are, the tuners, the bridge or the saddle and the nut, and a couple of other items. The first 10 I made, I didn't use any store-bought fixtures, but I did finally get a couple of pieces. This guy right here is, we'll go through them all individually, but this drills the hole in the peg head for the tuners. I did it before just with regular drills. This is all the stuff that you need. Like I said, I'm going to go over each one of these guys individually. Don't know how long it's going to take, but and I do have a guitar body. I always think of the guitar body, the guitar neck as the major components, and then each one of those has its own little workflow. When I first started making guitars, I didn't have the Agazzoni. I had the 6 1/4 by 10 1/4 Inca bandsaw, and I did not have, and of course my couple of table saws, drill press. I did not have the drum sander when I first started. I got this about a couple years after I'd done it, been making guitars, and it turned out it was really, it made things so convenient to make the tops and the backs and the sides. Before, I would simply just cut them as thin as I could on the little bandsaw and glue them together. Okay, I came back. I forgot to put the plate glue up fixture. I've done a video on this before. And like I said, we'll go through all these pieces one at a time. I decided to make a guitar, and it took me a month to come up with design profile, the shape that I want. It's not a copy of any guitar. It is a kind of some of the best measurements of some of the best guitars. And I came up with the top template, and that's where it all starts, right there. We'll start with the top template. This was a compilation of several guitars from the past. I took averages and several other dimensions. So for point of reference, this is the upper bout. That's upper bout, the waist, and the lower bout. I think what was important for me was to kind of figure the ratios of the length of the body to the biggest diameter of the lower bout, the relationship of the waist measurement to the lower bout, and also the relationship to the upper bout. So I came up with this design, and it is the basis for probably 60% of the guitars that I make. I make two sizes. If you notice on the first one that I did, the front and the back have a straight line component. That's for gluing on or make ease of gluing on the front and back blocks. But I wanted to make a little bit bigger one with a rounded lower bout. So you can see this is almost a nice radius all the way around. It just adds another step to the making of the rear block, which is not a problem at all. Now this does have a real, right here where the front block goes, this is where the neck attaches to the body, it is a flat. You can see it's just marginally different. And it's about lined up. So it was 5/8 or ½ inch bigger with the curved. Eventually I'll show you a couple of guitars made from each template. And it's amazing, but there is a lot of difference just in the small amount. They both sound good. The bigger one has a little bit more of a bass, a little bass response, really nice. There's a couple of different ways to bend the sides of the guitar, but I elected to do it in this manner where you actually form the sides, and then you use this as the bending form. The sides are about 40 to 60 thousandths, and they bend without heat. Sometimes I do spray it a little bit with water. This is for the walnut. I don't use anything but walnut. I'm sure with the harder woods, rosewood or something of that nature, you probably have to heat it up. I'm not opposed to doing it, but I really like making the walnut sides and back guitars. Again, this is the exact profile of the smaller version. And I've modified the sides for the clamping. Now this is the back of the guitar, and the part laying on the table is the front. Now there is a 90-degree angle from the top, from right here to right here, when you're gluing it up. On the back, it's less than, because the back actually slopes down. I don't know if you can see it, but there's actually it's taller in the back. It's a little bit taller in the back and a little shorter in the front. This is the fixture that I use to glue up the front, or the top and the back plates. The top is usually redwood. I've made spruce and others, but I prefer redwood top guitars with the walnut back and sides and a walnut neck. But this is the fixture that I use. I've done a demonstration on this before, and in the series, I'll go ahead and do I'll make a top and a back and video that. But this is the fixture that I use to make those. And here's another shop-made component. This is what I use for gluing the braces to the back and braces to the top. An important part of a guitar is the top has a 400, or the tops that I make have a 480-inch radius arc. And I don't know if you can, this is the fixture that or the template that I made. It's very slight. You can see that there's a real slight concavity. I made each one of these. You just strike. I made like 8 long pieces, and then cut them in half and put them together in this, and it works really great. Like I said, the top is 480-inch radius, and then the back is 144. Here's the back one up here. Same deal, and quite a bit more of an arc. It's important because it allows the top and the backs to expand and contract a little bit without breaking. Again, we'll show you. Then it's I'm not sure the name, a go bar clamp or fixture, and basically I use dowels. I'll put the top plate down, a brace, get them all lined up with glue on it, and then use this as the clamp. And you can see up here, and it puts a light but adequate amount of pressure. And I'll have about 10 of these. I'll glue up 2 or 3 braces with these dowels, use it as a clamp mechanism. It works really well. Every guitar I've made, I've used this system. Here's an example of the body. And we'll talk about the rosette. Okay, since we're here, I make all the rosettes in some method or other like this, and I cut them very thinly with the bandsaw. And how I make the dado into the top is I use this fixture right here. We'll take it over. Okay, this is the fixture that I use for cutting the rosettes. And you'll see there's 2 dowel pivots right here, and then one right here. And you can see where I've got the lines and another dowel. Well, this guy was, I made it, and I made it like this so I could adjust it very finely. And this actually cuts the rosette, and it creates the dado. These guys right here, if I pin it, put this in the top, this will cut the perfect dado around the top, and then I'll put it on this guy on this hole, and it'll cut the outside of the rosette, and then I put it on in this dowel right here, and it'll cut the inside, or vice versa. And it seems kind of impossible to do, but depending on how careful you are, you can cut them near perfect. And you can see I don't really see any negative parts. I don't see any places where it didn't work all that well. This guy right here is that'll be covered by the fretboard. Inside of the top are braced, and here's one of the templates that I use for a top brace there. This is about twice as big as it will be, reduced in weight and size, and made fairly nice. Now this is one of a cross brace. There's lots of different ways to brace a guitar top, but the way I do it on these is the cross brace like this. And there's other braces. We'll go through all that in another video. In the back, I use the same template for the tops and the back. And the backs have a little bit different bracing strategy, where these braces go across like that. And if you notice, there is that on the back, that 144 radius on these. You can see it rocks. I think it's pretty important for the radiuses for the resonation of the guitars. That's why I go to the time and trouble to do it. Since this is an overview, we're just going to show on the inside. You can see the back braces configuration. I'll do another video on each one of these components more in depth, because there's lots going on in here. You can see the kerfing on the sides, and there's blocking. I'm going to see if we can get in there and look at it. Yeah, you can see the front block